Hello, and let us start with paper 4 big data. Okay, we already you have studied in part 1 about business intelligence, and you know the basic idea. And with that assumption, let us check uh, that let us assume that you know entire things, and we will start with the big data. Now, in case of a big data, we are going to work on the data which will be used at the huge way. Okay, um, where we have used such type of a big data, we are using social sites, we are using search engine, where all these search engines, social sites, they need to process on these data. Okay, we are having large data at a time on these social sites, and the companies has to filter out, they need to work out, multiple queries has to be processed, and so on. So these many things they are going to do on this kind of data. So what kind of actually work we do with such a type of a data? Let's take an example of a Google. On the Google, we perform the searching. So search is it means we are filtering it. So while filtering, we are using lots of searching. Uh, we are performing multiple tasks on it. We also, the cookies has to be managed for each and everyone. Now at a time, multiple participants are using the Google. Similar way, if we are doing with the Facebook, the one person is uploading the data, one person is might downloading the data, one person might using searching for the friends, etc. So many tasks we perform on these websites, and these data are stored on their server side, and we need to manage it. We means the company or the owner, entrepreneur has to manage it. Now, today I'm not going to start with your unit 1. Unit 1 is about the basic theory, and which resembles with the little bit idea from the part 1. So I'm directly starting with the part 2 second unit, which is based on Mapreduce technique. So one of the technique which is employed by these sites for processing the data. Okay, so let us begin with the second unit. Hope so that you all can see the slides. We will be try to cover the minimum today only because of the net issue. Still, we'll go. The second unit is based on map reduce. Okay, as a name suggests, it's going to map somewhere and it is going to reduce the task. Whether it is going to reduce the task or what it is going to do, we'll explore it. Let us have the introduction about this map reduce. So, where this is mainly used? This is mainly used in distributed file systems. Okay, in DFS mainly this MapReduce is used. You can see the example Google or Hadoop, as we are having some practicals on the Hadoop. Mainly, two functions are written for this. One is a map function, another one is a reduce function. Now, what the map function is going to do? As the name suggests, it will try to form the mapping values. Mapping means what? If certain query is thrown, for example, let me search for a friend on a Facebook. If I'm searching for a friend on a Facebook, now on a Facebook, multiple users are logged in and or joined, and I need to search one of my friend on this Facebook. So I put a query. So I'll put a name in a search, and I'm trying to filter out it. So this is what is a task that user is given. Now the data will be stored all over the world because it is a distributed for India's location, for UK's location, for US's location, many locations will be there, and it need to search out. So what the map is going to do, it will perform the mapping with each and every one. So it will try to find out on each and every database whether the friend or the requested data is present or not. Okay, so you can see once we put it the data, you can see that there are filtered options coming outside. For example, suppose I'm putting the search value as a say Sushant. Okay, so if I'm putting Sushant, then it will give you the all the people logged on Facebook with name Sushant, and from that filter out data you are selecting one of your friend. So this is nothing but your reduced task. Okay, so what I have done is I have put a mapping value. So some input is given which will be accepted by the map function. It will map this value to each and every database value, and it will filter out the data. It will perform search operation. So all these will combine together and will be given to the reduce function. Now this reduce function will reduce minimum one and will be given back to you. So map and reduce, they will be come one after another. So map will work first and reduce will come later on. Okay, so let us go ahead with each one of these tasks. So it's a simple processing for map and reduce. What we see is, you can see here we have map task. Okay, sorry, we have here map task. Okay, so map task have the input chunks. So for example, what the chunk mean? Chunk means the elements which are formed with documents or the record. So searching for a friend. So this is what is element. So I'm performing 2 or 3 tasks at a time. So these 2 to 3 elements together will form a chunk, and these input chunk will be put it to the map task. Okay, so map task will always accept the chunks. And what is a chunk? Chunk means the element. How we form the element? Element will be formed with a document or the record. Okay, so as an example that I have just explained, I'm searching for a friend with a name Sushant, and I'm putting it on the as the input chunk now. So this is a one query that I have fired, and that will be received by Facebook on the map task. Okay, so what the map task is going to do? So from the map task, it will form the key value pair. So what you will see there, you can see the key value pairs K comma V. So what is the key here? Sushant will be a key, and what will be the value? The record which will match with the name Sushant. Okay, so this is how the key value pairs will be formed by map task. Now see that this record, okay, or these key value pairs will be multiple. Okay, Sushant name starting with the Sushant, the people will be many for the name Sushant. So it will try to collect these keys. So similar keys will be joined together and group of keys will be formed. So keys with the name Sushant. Even if we place some query with certain keywords, similar keywords or similar words we also obtain as a resultant value. So why these things happen? Because of this filtering technique which will be employed by this map task. So what it will try to do is, it will try to find out uh, the people with the name Sushant. Now these keys, Sushant and Thakur, Sushant Sathe, Sushant Launde, so many things are there. Okay, so all these peoples naming with the Sushant, having the keys end with the some other word will be grabbed or collected together by a function called as group by keys. Now, who will do or who will perform this task? Group by keys. This will be performed by master controller. Okay, so how it is shown in the diagram, keys with all their values. So Sushan and all the surnames together will be collected over here. Now, what will be the other way? Some of the person might have written Thakur Sushan. Okay, but it has a match Sushan. Okay, so keyword is match with the Sushan, but the value is will be Thakur. But since the main task is the Sushan has to come first and Thakur later on. Okay, so this is what is the main aim, and the name search is Thakur Sushan. So one keyword that will be matching with Thakur Sushan. So okay, I'll say that may get filtered out with as an output. This will be given all these keys with having such type of a key values will be collected together and will be given to the reduce task. Now, what the reduce task is going to do? Reduce task will try to find out the minimum from each one. Okay, and then the combined output will be given to you. Now, let us take one more example to same process. Okay, so what we have seen? We have seen the input chunks will be given to the map task. Map task according to the input chunks will form the key value pairs. Key value pairs according to the keys will be grouped together by master controller. Then master controller will be given these keys to the reduced task, and these reduced tasks will be combined together and form the combined output. This is what is the basic process of Mapreduce. Now let us take one more example and then we'll go further for the Mapreduce. Let us have a query to find or to count the number of word occurrences in multiple files. Okay, so what is our actual input? Multiple files, all the files. Okay, from one database. So from the database, there are 5 to 4 files that will form the input chunks will be given to the map task. Okay, so let us say that we have here 3 map tasks. Each one will get one file, and it will try to find out now the key value pair. What is the actual query in front of us? To count the occurrences of the word. So is a word. How many times is occurred in a file? How many times the occurred in a file? This is what is a job that has to be done through this system now. This is what is a query. So what the map task will do? It will form the key value pair. So each map task, one map task which receive one chunk will form the key value pair. Now here what will be the key? Key will be the word, and what will be the value? Value will be nothing but the occurrences of a word, 1, 2, 3, 4 and so on. So let us take an example. I'm having one file with the sentence, this is M.Sc class. Okay, so what the map task will do? It will form the key, this value will be 1. Okay, so this is a one key value pair has been formed from the one file. Is 1. So value is 1, key is. M.Sc is a key, occurrence is 1. So this is M.Sc class and 1. So key value pair we have formed from the one map task as a 4. Now second file will be taken by the map task and it will again try to find out the key value pairs. So suppose that file contains a statement, I am in M.Sc class. Okay, so I is a key, value will be 1. So this is one key value pair formed by this second map task and will be given to the group of keys, group by keys to the master controller. I am, so M is what will be another key, occurrence is 1. In will be a key, occurrence is 1. M.Sc. Now from this map task, M.Sc will be a key and value will be 1 right now. But when it will be given to the group by keys, okay, so when we will give all these key value pairs to the group by keys, what the group by keys will do? It will try to find out the similar keys. For example, M.Sc is a key which occur multiple times from the one map task, also from the another map task. Okay, so now the key is M.Sc, and what is the value obtained from the first map task? That is 1. From the second map task, we have obtained the value 1. 1 plus 1, that is 2. This is how a grouping of keys will be done. So for this group by keys, the output for the word M.Sc is 2. That means in the 2 to 3 files, M.Sc word occurred 2 times. Okay. Now this will be given to the reduce task. All these grouped keys will be given to the reducer. Okay. So what the reduce task will do? It will try to combine these value. Okay. So from the group by keys, we obtain this 1 time, I, maybe 3 times, and so on. So how the 3 will be written? I will be written I, comma 1, comma 1, comma 1. How the M.Sc will be written by group by keys? M.Sc is a key, comma 1, comma 1. This will be given to the reduce task. Now what is the job of this reduce task? This reduce task, each one will take few keys or few groups of keys, and it will try to reduce the values. So finally what you will get as an output as M.Sc 3 times, then I value occurred 3 times, this word occurs 1 time. This is what is a entire combined output. Put it in a one file will be obtained by reduce file. Now here the important task is the map task, how the key value pairs will be formed, how the reduce task will combine it, and how the output will be generated. Now map task will and reduce task will be always governed by master controller. Reduce task will always require help of combiner. Let us go ahead. Let us do with the map task again. We'll revise it. Map task requires input in the form of a chunk. Okay. So input will be element in a key value pair, tuple or a element means tuple or a document, and map tasks are producing the key value pairs. Okay. We have seen that in the diagram, input chunks will be given to the map task, and map task produces the key value pairs. These key value pairs will be given to the master controller. Okay. Now grouping the keys. This will be done through the master controller. Okay. How the master controller will work? As the name suggests, it is going to group the keys together. Now to group or to make combination, okay, it will form the search and it will filter out it, and then master controller is going to put it forward to the reducer. That means the reducer is the one which will perform the reduce task. Okay. Now what the master controller is going to do? That processor controller will decide how many reduce tasks there will be and who will perform which task. So for this reason, it will use the hash keys. Now what the hash keys means? Suppose we are having reduce task as R. So for example, here we are having 4 reduce tasks. Okay. So what the master controller is going to do? It is going to generate the hash keys which will map for 0 to 3. So R minus 1 keys will be generated. Hash keys. These are the keys which are different from the map task. It will not depend on the map task, but it will generate from 0 to R minus 1. Now, what the next task it will do? So let us go with the diagram and let us try to get the idea of the master controller. Now already master controller has grouped the keys, and um, just a second. Yeah, master controller has grouped the keys. Now master controller knows how many reducers are there. So let's say we are having here 4. So total R is equal to 4. R is nothing but a number of reduced tasks. So what it is going to generate? It will generate hash keys for 0 to R minus 1 reduced task. 0 to R minus 1. So here how many keys we are going to generate? 0 to 3 hash keys we are going to generate. So some value we have obtained. Okay, for 0 to 3 we have some obtained hash key values. Now it will try to match for the actual keys generated for this map task. Okay, let us go with the example. Suppose I have generated the hash keys for first zeroth reduce key. For this zeroth reduce task, suppose I have created one hash key value, which is might be say number 345. If suppose this hash key value 345 matches with the say memory location, or maybe the actual key of the map task, then that keys will be given to the reduce task. Are you getting this point? Okay, let me go with more example. We have done with M.Sc. Okay, let's say this M.Sc is stored somewhere in a memory 345. Hash key value is a 345. It means that for the zeroth reducer, that is this is a first reducer, and to this zeroth reducer we will assign that M.Sc1. So this reducer is going to reduce or combine these values. Okay, so ultimately M.Sc value occurred 3 times in all the files, that will be combining will be performed by this zeroth one. Or sometimes it may happen that we have the key values as a 345 only, and hash key value is 345. So there is a match between the map key value and the hash key value. So this hash key value, suppose it is generated for say second reducer, then this second reducer will get the task. This is how the key value will be randomly assigned to the random task, and this random task with the help of random, not a random, reduced task. Reduced task with the help of combiner will combine all the keys together and will provide the output. So this is what is the job of a master controller. Is it a limited task to the master controller that it is going to group the keys and it will create the hash keys? No, it has to keep a track of all the map task and the reduce task also. So this is what is a reduce task. It is output of a reduce function is a sequence of 0 or more key value pairs. So just we have seen here that we are going to create 0 whatever the key value pairs that will be received from the grouping by keys will be get collected together by the reduce function, and it will form their own key value pairs. And who is going to perform this reduce task? It will be executed by the reducer. Okay, and all these things will be merged together in a single file, and this single file will be done through the combiners. Now this combiners where it resides? Combiners will be resides at this point, which is going to get the output value from the reducer and will form your final output. So what the combiner is going to do? When the reduce function is associative and commutative, we can push some of what the reducer do to the map task. So we are, whatever map task is going to divide with this one will be collected together with the combiner, and combiner is going to replace it by a single key. So this is what is the example that is given. Let us go back to the diagram and let us go with the example. Here we have taken that the M.Sc is a key created by first map task, second map task has also created the M.Sc key, and this will be collected by the group by keys. So this is how the combiner is going to work. Now here also all these key values coming from each one user has to be put it in a single file. So here the combiner will work. Okay. Let us go with the execution. In depth, this is the execution of a MapReduce programmer. We have just seen the input data, which is in the form of a chunks. This is our actual working. Okay. Here we have the workers. Okay. These workers are nothing but your map task. This is what is the keys or the output generated by the map task. Okay. These will be grouped together by this master controller. Okay. Here what we have is the reducers, and reducer will put all their work in the output file. Now to process from input to output, there should be someone who will control all these things. So there is a master who is going to assign the map values and who is going to assign the reduce work. Now there must be someone who will say something to the master that now the work has to be started for finding or searching or the producing the output for the query. So user is a program. We write the program. We write the map and reduce function, which will fork the master, which will invoke the master. Also, it will fork the map task, which will fork the reduce task. You can see this is the actual working execution of your map reduce task. So we already seen this much process in depth in our first diagram. Let us go here. Here we have the user program, in which we have the map task as well as we have the reduce task. So from this user program, whatever input files that will be received by this map task will get forked out. Forked out means it is going to invoke it. Along with that, it will invoke the master to assign the values to each one of this worker. Now this worker here means the various stations. Okay. Hello. Hello. Okay. There is a problem of electricity. Sorry. So master is also going to assign next reduce task, and user program has to fork it. Now we have explained with what the master is going to do and so on. Also, master need to manage some more tasks. The more task is coping with node failure. Where is a node? This is what is a node. Okay, workstation node. See, map task is workstations perform. We need to execute your task. What happens if some of the node gets failure? It may happen that it will failure on the map side, or it will be failed on the reducer side. Okay. So what the what the master has to do? Now, two types of a failure that master has to control. One is a failure at map task, and second is a failure at reduce task. Now, failure at a map task is managing a little bit difficult, but failure at reduce task can be managed very easier because each thing is known by the master. Now let us take the easiest case first, that is a failure at a reduced task. Let us go with this diagram to explain the failure at reduced task. So where the failure is going to work out. Let's say that gets failed. Okay. Now master needs to knows that, correct? So let's say from 1 and 2, this worker takes the input. So what the master will do? Master will again assign the second worker, because master has already locked its assignment. Okay, so it's very easier for the master to get the work which is assigned to this node, and immediately it will be received on this node side once the node is getting filled. So if it is completely filled, so worker may get removed from the file. Now what happens if the failure occurs at map site? So let's say this first worker done failed with some system problem, or maybe with some other case. Now this worker, it is going to receive the data from the worker. Now again the master has failed, or worker may get in a working position later on. So if it is completely failed, so worker is completely failed, then what the master is going to do? It is going to reshuffle entire task to the others. If not, and worker might start its work again, then from the input it will has to assign or search for the element that is assigned to that node, and then that worker will receive the node and start its work again. Again all the keys will be recorded to the master again has to perform the grouping of keys. These grouping of keys will be again one map station or map node gets filled, master has to start the work from initial. Whereas if we have a node failure at reducer, then it will be easier because everything is loaded, just assignment has to be done. But if the map node failed at any point of a time, then master has to start its work from the initial node. It will start from the input data assignment, forming the keys, loading the keys, forming the hash key values, assigning that hash values to the reducers. The reducer might get a different task other than previously assigned, or there is some cases that master need to handle, because it might possible that reducer has already done the work and it is now putting it in the output file. So everything that master has to manage if the node is getting failure on the map site. Okay, now that's it for today, and next week whenever we will meet, at that point we will start with algorithms. So you may all leave today's session